Hello students, in this video we'll discuss about introduction to languages and operations on language. So this is the first concept in automata, languages and computation. So what is first finite automata? See, the formal definition of finite automata is it is a mathematical representation of formal languages. So the languages what we have like Telugu, Hindi, English, these are all natural languages, but it's going to represent only the formal languages. What does it mean? See, when you can say that a language is a formal language, so there must exist a grammar to recognize it. See, not all the natural languages are having the grammar. For example, if you take some tribal languages, even they don't have the alphabet, so there is no grammar, and there should be an alphabet to recognize that language. So not all natural languages are having, but if you are saying that it is a formal language, and there should be some machine to accept that language, right? And we should have some restrictions, at least one restrictions, like it should starts with something or ends with something, or it should have something like that. So our automata is going to model such kind of languages, not all the languages. And the informal definition of the same finite automata is just model the behavior of a person or a student. I mean, say that person, of course, or we can say that a system, right? See, I just want to model the behavior of an electrical fan. Then, what are the states of a fan? At any point of time, the fan must be in the running state or it must be in the idle state. And these are the two states. And the starting state, initial state, is denoted with the idle, the initial state of the fan. And when you are accepting it, when it is running, then we are denoting the accepting state or final state with the double circle. Then what are the inputs we are giving to the fan? So there are two inputs, one is on and off. So if the fan is in idle state and the input given to the fan is on, when it is in idle, if the input is given is on, then it changes the state from idle to running. The fan is in idle. After taking an input symbol like off, then it won't changes its state, it will be in the idle only. Same way running. While the fan is running, if the input given to the fan is on, it would be in the same state. If it is off, it changes its state from running to idle. That's it. So this is called automata. Like that, something which is going to be model the behavior of a person or a system or a formal language can be treated as a finite automata. Like for example, if you take the example of door and we are having two, either it should be in the open or closed door. So when it is closed, if you open it, then it changes its state from closed to open. Same when it is open, and if you close the door, and it changes its state from open to close. So these are called as transitions or edges, and these circles are denoted with the states. And the entry, what would be the starting state here, that is denoted with an empty state, right? Empty transition. And before going to the construction, let me discuss some basic concepts of finite automata. So what is symbol? Symbol can be anything, guys, right? For example, if I write something like it, if you know Telugu, then you may state that it is a Telugu symbol. Otherwise, that should be treated as a normal symbol. Like if you take this a symbol, or if you take something, if I write like this, no one knows it, right? It's also a symbol for you, right? Might be if I write something like this, that's a symbol. But this is 3 in Telugu numbers, right? Like if you know it, or if it is having some meaning or not having, that should be treated as a symbol. Like dot in mathematics, no for particular definition. And alphabet is denoted with the sigma, and this alphabet is nothing but finite set of symbols. For example, if I take it 0 comma 1, the binary alphabet, if I take it a comma b comma so on z, so the number of symbols in the alphabet must be finite. And string or word, it is denoted with the W or S. A string is nothing but set of symbols, right? Collection of symbols derived from a single alphabet. For example, I can take the 0110. I can say that it is a string derived from first alphabet. I can say that A, B, C, B, A, something like this. This is derived from the alphabet too. But if I write something like this, 0, A, B, this is not a string because we have taken the symbols from two different alphabets. That is not allowed. The length of the string is denoted with the mod W, right? So the number of symbols from the alphabet, just count the number of symbols which are from the alphabet, that is length of the string. Right here, what is the length of this string? 0 is occurred 2 times, 1 is occurred 2 times, can be treated as 4. And here, see, A is occurred 2 times, B is occurred 2 times, C is occurred 1 time, D 0 time, like that. Just count the numbers, then the length is 5 here. For example, if I take my alphabet like this, 0, 0, 1, you can take it, guys. There is no restriction that alphabet must not be having like this. See, B, we'll take it as 1 and 3. That should be treated as B in English. That's my wish when you are writing your own alphabet. If my string is 00100, the length of this string is 3 because 00 is used 2 times and 1 is used 1 time. So length of the string must be from the alphabet. Null string. See, if the length of the string is 0, the only string in the complete subject whose length is 0 is epsilon or null string. And it is not with epsilon symbol, sometimes lambda, sometimes cap. So they'll tell you in the question what it would be. The concatenation of the strings, for example, if you are having W1 is 10 and W2 is 01, then the concatenation is denoted with W1 concatenation W2. It is nothing but 1001 is not same like W2 concatenation W1. It is 0110. And see, if you concatenate epsilon with any string, you'll get the same string. Like, see, W1 concatenation W3 will give you 10 concatenation epsilon. It is nothing but 10. So prefix or suffix of a strings, right? So then we can say that, for example, if my string is MAKE, the prefixes are nothing but the strings which are derived from the left hand side, but don't skip the symbols in middle. Like the possible prefixes are, you can take 0 length strings, epsilon, M, 1 length, 2 length, MA, but don't take A because you are going to skip M. Don't take MK, we are going to skip A. That's not from the left side. MAK, prefixes, MAKE. And same way suffixes means you have to take the trailing symbols from the right side. You have to take same. 0 length means epsilon, 1 length means E, 2 length means KE, 3 length means AKE, 4 length means MAKE, like this. So prefixes are suffixes, right? Substring means you can take from anywhere, right? No need to from the left side or right side. You can take from anywhere, from middle also, but don't skip the symbols. Like from the left hand side, you can take all epsilon, 0 length. 1 length means you can take from anywhere. So I can take MAKE. You can take 1. 2 length means you can take MAAKKE. But don't take MK or AE. That's not allowed. 3 length means MAK or AK. You can take from anywhere but don't skip the symbols in middle. 4 length means MAKE. That's a substring. It's a string or part of the string. Then the clean closure of an alphabet. For example, if my alphabet is 0, 1, the clean closure of the alphabet is denoted with the star, sigma star. Then you can take star means 0 to infinite, guys. So sigma power 0 union, sigma power 1 union, sigma power 2 union, sigma power 3, so on. Right? So what does it mean by sigma power 0? Right? So 0 length strings, nothing but epsilon. 1 means you take the alphabet 1 time, that is 0, 1. So 2 means take the alphabet 2 times, that is 0, 1 concatenation 0, 1 will give you 0, 0, 0, 1, 1, 0, 1, 1. Same way, sigma power 3 means you take the alphabet 3 times, 0, 1, 0, 1, 0, 1. Just perform the concatenation of the sigma square with the sigma. Will give you concatenate this 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, like 1, 0, 0. You can take it 1, 0, 1, 1, 1, 0, 1, 1, 1. So combination of all will be treated as clean closure. And we have a positive closure that is denoted with the sigma plus, where you should take it from the 1, sigma 1, sigma 2, sigma 3. Just you should not have the epsilon in the positive closure. So the clean closure is nothing but from the positive closure, sorry, the positive closure is nothing but from the clean closure you have to remove the epsilon, right? A language is nothing but collection of strings and it is denoted with the L. The clean closure is sigma star. So a language sometimes can be empty, no strings in it, and that is denoted with the empty. Sometimes it may have some strings like finite number of strings. We are having 2 strings. Sometimes it may have infinite number of strings, 0, 0, 0, 1, 0, so on like that. And we are having some operations. We can perform some operations on language. For example, if I'll take a language like L equivalent to 0, 1, 0, right, and 1, 0, okay, 1, 0, 1, 1, then the L2. So what is the L1 union L2? It is nothing but you have to take all the strings. If they are repeated, don't take it. So 1, 0, 1, 0, 1 and 1. That is same as L2 union L1. The concatenation is nothing but L1 concatenation L2. Then you have to perform the concatenation of each and every string. First 0 with 0, 1, 0, 1, 0, 1. Same way you have to perform each and every string from year to year. So 1, 0, 1, 0, 1, 1, 0, 1. So this may not be equivalent to L2 concatenation L1. You can do it. Then intersection means you have to take the common symbols of L1 into L2. As there is no common symbol, then you can take it as empty set. For example, if I'm having another language like L3 equivalent to 1, then what is the L2 intersection L3? That should be treated as 1, right? Same way reverse, you have to perform the string reverse like L2 reverse or L1 reverse, you take it. Just perform the reverse of the string. 0 reverse is 0, 1 0 reverse is 0 1. Just you have to perform the reverse of the strings. And difference, right, it is denoted with the L1 minus L2, right? Reverse means L1 power R, intersection means L1 intersection L2, L1 concatenation L2, L1 plus L2, and L1 star, this will discuss, and L1 complement or L complement, whatever it is. So then what is the difference, right? Let me explain with a new, right? So for example, if I'm having a language like L1 equivalent to 0, 1, 0, 1 and L2 equivalent to 1, 1, 1. So what is L1 minus L2? You have to take the strings of L1 which are not in L2. 0 is not there, then you can take it. 1, 0 is not there, you can take it. But 1 is in the L2, that's why you are not supposed to take it. That's it. L1 minus L2 means you have to take the strings of L1 which are not in L2. So 0 is not there, 1 0 is not there, but 1 is there. Then L2 minus L1. You have to take the strings of L2 which are not in L1. So 1 is in L1, don't take it. 1 1 is not there, then take it. That is the meaning of difference. Then L1 closure, right? It is nothing but you have to take L1 power 0, L1 power 1, L1 power 2, so on like that. Same way. L1 power 0 should be epsilon. The only string whose length is 0 is epsilon. Take the L1 one time, means 0, 1, 0, 1. That's it. Take L1 two times. Perform the concatenation of 0, 1, 0, 1. Concatenation 0, 1, 0, 1. So what it is going to have? 0 concatenation 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, sorry. Then same way 1 0 concatenation with all 1 0 0, 1 0 1 0, 1 0 1. Then 1 concatenation with all 1 0, 1 1 0, 1 1. Right. So this is about clean closure. So let me go with the complement, and that is denoted with the sigma star minus L. Right. Okay, sigma star minus L means, for example, if you are having an alphabet of 0, 1, the universal language is going to have everything like epsilon 0, 1, 1, 0, 1, 1, right, 0, 1, so on. Then if the L is epsilon, then the L complement is you have to take all the strings of sigma star which are not in L. Means you should take 0, 1, 1, 0, 1, 1, so on. Just you have to remove it. That's it. We'll discuss more about this in the next video also.